Welcome to ClickMyProject.com. Now we are going to discuss about the project Urinary Stone Segmentation in Abdominal X-ray Images using Cascade Unit Pipeline with Stone Embedding, Augmentation and Lesion Size Reweighting Approach. Now we are going to discuss about the abstract of the process. A urinary stone or renal calculi is one of the most frequent abnormalities in the urinary system. Each year, more than 500,000 of people visit the emergency rooms for urinary stones problem. Computer-assigned deduction techniques developed to improve the diagnosis without the multiple systematic readings have not resulted in the significant improvements in performance measures. In this process, the use of automatic image processing technique resulting from the machine learning methods represents a deductions and classification of kidney stones in medical imaging method, as well as the performance of the process is evaluated by means of the accuracy. The overall process having the three stages like the segmentation, feature extraction and classification. By these three steps only, the project plays a major role to diagnosis whether the urinary stone has occurred or not in the medical images. In case of urinary stones has occurred, the pop-up message will be displayed as unhealthy images, or else if the input image is having the patient having the normal without having the kidney stones, in the sense it will display the pop-up as the normal. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this project. The project consists of the steps like input image, pre-processing, segmentation, feature extraction, classification, and finally performance estimation. At first, the kidney image is taken from the dataset. The dataset consists both the stone image as well as the normal image, which means the healthy and unhealthy images. After taking any one image as an input, the pre-processing will be carried out. In this pre-processing, not only the grayscale, before going to the grayscale, we have two stages. One is the image resize, then the another one is the channel separation. So in this image resize, the image will be resized into one size of 224 cross 224, which means the number of row in the image and the number of column in the image will be the 224 sizes. After doing this one, the image will be separated into one red, green and blue channels. Basically, the RGB image having the three kinds of channels will be there: red, green and blue. In case of medical images having the grayscale contrast, in the sense directly the image will be the grayscale. After doing the pre-processing, the feature extraction will be carried out. In this feature extraction, majorly we have an local binary pattern, and then subdivisionally we have applying the deep learning by means of the convolutional neural network. In this feature extraction step, local binary pattern is used to extract the pattern features from the images from the segmented image. After doing the feature extraction, the classification is done by using the machine learning technique to classify whether the input image is normal or abnormal. In case of normal, the classification result will produce the result as normal, or else the abnormal, the classification result will produce the result as unhealthy. After doing the classification, the performance estimation will be carried out. In this performance estimation, we have three kinds of performance like accuracy, sensitivity and specificity. Majorly we have concentrated on the accuracy. In case of accuracy is high, the precision of the performance is high. Now we are going to discuss about the running procedure of the project. At first, open the Spider 3.7. After that, you have to change the current directory like this. After doing the changing the directory, we have to open the mainfile.py. This is the executable file. After opening the mainfile.py, we have to click the button run. After clicking the button run, the dataset will be open. In the dataset we have both the healthy and stone images. After opening the dataset, we have to select any one image from the dataset. The corresponding image will be processed one by one, and then those results are shown in the console. Now we can discuss the results one by one. First of all, the input image is shown in the console in the title of original image. This is the image we have selected from the user. After doing the selection of the input image, we just move to the second stage of the project, that is the pre-processing. Here the pre-processing size is 224 x 224. After doing the resize, the image is directly converted into one grayscale form. In case if the input image is having the RGB channel, that is the red, green, blue, the image will be automatically converted into one grayscale form. After doing the conversion of the grayscale, the segmentation is carried out. In this segmentation, the pixels will be segmented. In case of any large amount of kidney stone is present, the image will be visibly seen, or else the data type will not be shown in this one. After doing the segmentation, the feature extraction will be carried out. So before that, we have to separate the data into one test and train separately. We have an 80-20 ratio for the test train separations, 20% for testing and 80% for training. After doing this one, the convolutional neural network is applied to extract the initial features from the image. After doing the extraction of the initial features, the pattern feature is extracted by means of the local binary pattern. This is the image represents the local binary pattern. After doing the feature extraction, those feature values are shown here. We have extracted the test feature from the input image. Likewise, we have train features in the for all the dataset images. After doing the feature extraction, everything, we just doing the classification by means of the machine learning, whether we can identify whether the input image is the stone image or not. After doing the classification accuracies are displayed here. Thanks for watching this video.